Hello all, and welcome to the first video lecture of the school year for Honors Math Theory. For each of our different topics, our different objectives, you're going to have a similar assignment to what you see today, where you've got a video like this. You'll have the lesson plan notes, both blank and filled in, so the blanks will look like this. If you keep scrolling on that PDF, there's filled in. You'll also have what's called a homework nomination form. So once you've taken the notes, either by reading over the guided notes and the lesson plan very carefully, though I do encourage taking some notes from video as well, just because it's a little bit easier to follow in some cases. You're going to do the homework from your reader. Now, just like with previous classes, they have the answers in the back. One thing as we get towards proofs is talking about writing things in your own words. All those sort of academic honesty things are going to become really important, but I wanted to hand those out first just so that you had all the tools at your disposal. So you'll work through these, you'll check your answers in the back of the book, and then you'll have the opportunity to nominate any problems that you're stuck on, just like we would in class, remember, like with hand raising, except for it's going to be in a Google form, and that's going to be attached to each assignment. So, for example, if you've worked through it, but you're like, I just really don't get 31, you can just go in and nominate 31 on the form. Because a problem's nominated doesn't necessarily mean I will go over every single one, but certainly if two of you or all three of you are stuck on the same problem, I'll definitely go over it then. And then once you've checked those answers, you're feeling good. If you're feeling great about that, you can post the presentation problem as a picture, just like you may have done in other classes. I'm not super picky about what format it is, but please just attach the picture. You don't need to put it like in a document or anything like that. And make sure that the contrast is good enough that I can read it and that you've shown all your work. So sometimes students are like really far zoomed back or they're really blurry and I can't read it. But that's about it. If you have questions on any of the material and you haven't had your one-on-one meeting or you've had it and you have new questions, please post it in the comments, shoot me an email, whichever method makes the most sense for you. These videos, it's obviously a very advanced honors class. These videos are going to be a bit longer. We will eventually have really pretty long videos, but I'll build in some work days to offset it so that you're at most doing maybe an hour of math a day. But you will be doing, as we progress farther, you're going to be doing more than that 30 to 35 minutes for this level of class, but we're going to start off with aiming for about that ratio just as we begin the year so that you're not completely overwhelmed. So the videos and the lesson plans will always look like this. They'll have the objective, so the topic that we're doing, they'll have the homework assignment, and then we'll have notes and then problems next to it. So when we're talking about notes, today we're going to say, describe sets with set notation. So we're going to start by defining what a set is. Now, a set is a very broad definition. It's just a collection of objects. Now, usually these are numbers, variables, ordered pairs, things like that in math, things that appear in math, but a set could be anything. This is how it'll normally go in the video, is that I'll either have something typed up and it'll just appear so that you're not watching me type everything out, or I'll be writing. So a set is a collection of objects, and these objects are sometimes called elements. And the way that we show that something's an element is, you see like here in the problem, we'd read this as X is an element of the set N. So it kind of looks like an E, stands for element. So what it means is that X is in this collection. Now you'll notice that there's these sort of weird looking letters that got an extra line in them. They appear over here. These are some specific sets that you will want to know in this class. So the first set, this N with an extra line in it, is the natural numbers. And the natural numbers are just your whole numbers. So we might write them out in a set as, and sets are started with a bracket, as you can see over here, or braces. Natural numbers would be just like 1, 2, 3, 4, etc. So you'll notice that they're all positive, and we're not including 0 because they're all positive. The next one is this Z with the extra line in it. These are the integers. And these are your whole numbers plus all the negatives. So you'll see dot, 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 and then maybe -2, -1, 0, 1. So it's the natural numbers plus all those negatives and zeros. Next is R with the extra lines, and these are your real numbers. And I can't actually write out a list of those because those are all the numbers, like I have for these ones, those are all the numbers on a number line. So I could write pi, 7, -2/3, they're infinite. And not in an infinite way that's listable, and we'll actually talk about that later in the course. You can't make a list, real numbers, just all the numbers on the number line. And then this last one, which is a 0, looks like a 0 with a strike through it, like this. This is called the null set. And the null set is a set that doesn't contain anything. You can think about it like an empty room. The room exists, the set exists, but it's completely empty. So it kind of almost look like that with the braces with nothing inside of it. So those are the big important things for sets, and then these 4 first ones. So a lot of set notation is written like this, not in just long lists, because as you can see, we get ones that are very weird to list. So the first one, we say, write the following sets by listing their elements between braces. So making sure that you can interpret this type of set writing and interpret it into a visual. So the way we'd read this here is we'd say X is an element of the natural numbers. So that tells us the type of terms we're looking at. So only natural numbers are going to be in this set, and we're looking at a specific subset of the natural numbers. X is a composite number. So if you remember, that means that it's not prime. And so if I was going to list them out, the first composite number, if we're looking through the list, we've got 1, that's not composite, 2 is prime, 3 is prime, 4 is the first one with factors. So 4, 5 is prime, 6, 7 is prime, 8, 9, 10, 11's prime, and if it's an infinite set like this, you can eventually just do dot, 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 and so on. So this is just, again, making sure that you can read a set element like this. Now, you'll notice here with B and C, these two are very similar, but we're drawing from different types of terms. So what this one's saying is that this set is made of all the integers where n squared minus 5 equals 0. Here would be where n is all the real numbers, where this is true. And so in this case, you're going to apply a little bit of logic. If I know if n squared minus 5 equals 0, that means that n is equal to the positive or negative root of 5. Now, neither the positive nor the negative root of 5 are integers, so this set B is the null set, right? There's nothing in it because there aren't any integers that satisfy this equation. On the other hand, negative and positive root 5 are real numbers, so for C, we list them out in order. First the negative from smallest to largest, and then the positive root 5. So that set has 2 elements in it. So speaking of interpreting it here, you're also going to be asked to say, okay, here's a set written out. Please put it into a format that's more organized like this. And this is called set builder notation. And it's what we've been seeing up until now in number 1. And it's basically a way to write large or infinite sets. So when you're translating between a long infinite list, we can see it's infinite with the 2 dot dot dots, you're going to go through 2 separate steps. The first thing you're going to do is, just like in problems in number 1, we're going to start by identifying what type of number we're looking at. So in this case, we've got -2, -4, 0, 2, 4, 6, 8. So those are all integers. And so that's how we're going to start ourselves off. We're going to say, oh, well, I'm interested in X in the integer group. So we're going to do the Z with the long line. And then we'll talk about the specific part here. So one thing you can notice is you can just write this out. It's like, oh, -2, 4, 0, all of these are all the even numbers. So you can just write out, just like it wrote x is composite, x is even. Another way you could write this same set is you'll notice even numbers are all multiples of 2. If you want to write multiples of 2, you can say, okay, well, I'm talking about all the multiples of 2 where x is in the integers. So you'll notice here you're allowed to put the specificity in either order. You're just going to end up with a bracket here and then the ending. It just depends on which one makes more logical sense in terms of our language skills. So here we're saying the integers where they're even. Here we're going to say the multiples of x where x is an integer. Right? Because if we talked about all the integers, we're talking about 2x, that feels a little awkward. So think about the way you would explain it in English. Another important thing about sets is cardinality. And cardinality is just asking about the number of elements in a set or its size. And the way that we use to show that is you'll see here it's the set's name inside absolute value marks. Think about like magnitude of a vector. So the absolute value lines or the magnitude of the vector show that we're talking about the cardinality. And then a set will usually have its name as just a capital letter, just like how like maybe like a vertex of a shape or something like that. So the name of the set. And we're going to talk about finite ones. So this could equal a number if it's a finite set, but it also could be infinite, right? We think about the types of numbers that we were just looking at, like the integers, that's an infinite set. So you can write that it's infinite like that. Now, if we're asking to find the cardinality of A, given A is equal to the set of the integers where the absolute value of 2x plus 1 is less than 5. So what you'll often do is when you see an equation, you just want to start by solving it, because what this is asking is the integers that are the solution to this equation. So let's start by quickly solving absolute value. Now the way we want to start that is splitting it up. So -5 is less than 2x plus 1, which is less than 5. So now we split up the absolute value into its two bounds. We then subtract 1 from both sides, and we're left with -6 is less than 2x, which is less than 4, and then divide by 2. So -3 is less than x, which is less than 2. Now, if we're stuck on then the next question, which is how many integers is this, I might even draw it out on a number line. So if I'm going from -3 to 2, these are open bounds, because you'll notice here we started with an open boundary. In between these, we're only looking at the integers. So we're looking at 1, 0, -1, and -2. So these numbers here are the set A, and then the cardinality of A, the number of elements it has, is 4. It has the elements -1, -2, 0, and +1. Here for question 4, we have find the cardinality of A, where we've got like a set and we have so many brackets. Sets can have sets as their element. So sometimes it's nice to list out the elements of A as like a bullet list. So you can say, okay, the first one, we go past this first bracket. This first element is a set that contains A, B. And then we hit a comma. We end the bracket, we hit a comma. So it's almost like a grammar lesson. The next one is A, the next one is B, and then the final element is the null set. So again, like I said, we're looking at a set that contains sets, which is absolutely fine. Sets are just collections of anything, and we can see we have, once again, 4 elements. The last really common type of set that we haven't talked about yet is on the coordinate plane. As I said sets can be variables, numbers, ordered pairs. This is very common. I'm going to do a little edit here, make sure that that's going to be just a bracket using interval notation. So this is saying sketch all the points, all the coordinate points, where x is in between 1 and 2. So if I'm looking at this graph, x is between 1 and 2, and y is between -1 and -2 on the y-axis. So this is actually going to end up being a little rectangle here, because this is the space where all the x values are 1 to 2, and all the y values are -1 to +1. And so all these points are in this space here. I know that this class is going to have longer videos than most. We're going to make sure that we're using our Wednesdays as just time to catch up and work on the problems so that you're not spending an hour every single day on math. That's not my goal. But we will be having, the goal is 2 lessons the vast majority of weeks, and then hopefully the homework will be a little bit later. So let me know if you have any questions or are confused about anything that you have seen either about the class or about set notation in the comments or by email, whichever is easiest for you. Have a good day.